Okay, let's look at the concept of conditional probability. Now this is in contrast to independence, which we looked at in the last video. Independence, if two events are independent, it means that one doesn't affect the other. So they don't affect each other. In conditional probability, one of them does affect the other. So what that means is if one of the events happens, the probability of the other one happening changes, and that means that one event is conditional or dependent on another event. Now, the clue for thinking about the idea of conditional probability is seeing the phrase given or given that. And the minute you see that, you know that one of the events is dependent upon the other one, so they are conditional. Now, we use the line like that to represent given that. So given that A has occurred, B occurs. And we might say, what's the probability of B occurring given that A is occurring? So that means if A has happened, what's the probability that B also happens? Now, in terms of thinking about a Venn diagram, what that means is we're going to do something called restricting the sample space. When we restrict the sample space, it means we only think about the fact that A has happened. So we are within this circle here. That means none of this has happened, or we're not interested in that bit, that's all gone. This has not happened either, that's all gone. We are only interested in A happening. So we have restricted our sample space to A alone. Now, let's have a look at this with some numbers to help. Example 3 tells us that in a cohort of Year 12 students, of Year 12 there are 75 students. We're told how many study only humanities, only sciences, or both, and we're asked to draw a two-way table to represent this. Now a two-way table looks like this. When you have two conditions, in this case humanities and sciences, we draw the table like this, and we're going to have across the top, humanities can occur or it can not occur. So that means a student could study humanities or they could not study humanities. And we always put total there. Now down the side, let's do sciences. So they could study science or they could not study science. And again, we'll have the totals here. Now let's have a look at populating this. So we have 75 students altogether. So 75 goes there. 25 students study humanities only. Where does humanities only happen? So this is the humanities column. If it's this one is humanities and sciences, this is humanities and not sciences. So this is humanities only. So 25 students there. Similarly, for sciences only, that's going to be not sciences and humanities, but sciences and not humanities. So that's 37 students there. And then finally, 11 students study both. So that goes here because this is sciences and humanities. Now let's fill in the gaps. So across here we have got 48, and then down here we have got 36. Here we have got 39, which makes 2 students there, which means that's 27, but I worked that out horizontally, so we're just going to double check it vertically. 48 and 27 would be 65, 75, yeah, so that works. Now we can answer the questions. So first of all, we're asked, what's the probability that a student doesn't study science and they also don't study humanities? So the intersection of not sciences and not humanities. That's these 2 students here. So our probability is 2 out of 75. Now, be careful when we get to these 2 questions, because now we're using the given that line, which means we're going to restrict our sample space. Let's think about what this really means. What's the probability that a student studies science given that they study humanities? So what that means is we know they study humanities, so we know they are in this column here, so we're only interested in those 36 students. So we've restricted our sample space to these 36. Now within those 36, of them, what's the probability that somebody studies science? Well, there are 11 students who study science, so that's our answer. Now, for the last one, we have a different sample space that's a restriction to apply. What's the probability that somebody studies humanities given that they don't study science? Now, not studying science is this row here. So that means we're only interested in those 27 students, and that's our restricted sample space. Of those 27, the probability that somebody studies humanities is here. So that's 25 out of 27. We don't need to worry about decimals. We can leave our answers as fractions, and that's absolutely fine. Let's look at example 4. Example 4 says that two four-sided dice are thrown together, and we work out the sum of the numbers shown on the dice. We're asked first of all to draw a sample space. A sample space is a probability diagram that shows all of the possible outcomes. So we've got die 1 can show a 1, 2, 3 or 4. Die 2 can show a 1, 2, 3 or 4, and we're asked to sum up the numbers on the dice. So 1 add 1 is 2, 1 add 2 is 3, and so on. Here we've got 2 add 1. Here we've got 2 add 2. And there we've got similar. Here we've got 3 add 3. 3 add 4 is 7, 4 add 4 is 8. So there's our sample space diagram, and we can see all the possible outcomes. We can see that the most likely outcome is rolling a 5, for instance, and the probability of rolling a 5, I'm just going to put this as an example because it's not in the question, the probability of rolling a sum of 5 is going to be 2, 3, 4 out of 16 possible outcomes, or a quarter, for instance. But the probability of having a sum of 8 would be only 1 out of 16. So that's an example there, not part of the actual question. Let's look at the question. We're asked to find the probability that the sum on the dice is 5, given that at least one of them has landed on a 3. Now, the minute you see given that, we remember we've got to restrict the sample space to this thing here, at least one die landing on a 3. And what we're asked to find is the probability that the sum is 5, given that at least one of them is a 3. So let's restrict our sample space. At least one is a 3, so that means this one could be a 3, or this die could be a 3, or they could both be a 3, because that's at least one die landing on a 3. Now, that means we restrict our sample space to these outcomes here. How many are there? 1, 2, 3, 4, 5, 6, 7, because I don't want to count this one twice. So we've got 7 possible outcomes. Of those 7, how many of them represent the sum being 5? That's this one and this one, so it's 2/7. Now, part C asks us what assumption we have made for our calculations here when we are modelling this scenario. So we need to think about, for all of this that we've just written down to be true, what have we assumed has happened in real life? Well, for instance, we have assumed that both the dice are fair, that neither of them is biased. So let's put that as our assumption. Both dice are fair. But what does that mean? That means that all of these outcomes are equally likely. So let's put that in as well. All the outcomes are equally likely. There we go. So you can now have a go at exercise 2B.